This is what's known as an acid-catalyzed ester hydrolysis, where you have an ester and then an acid catalyst, and you hydrolyze it into the corresponding carboxylic acid and alcohol. So here we have ethyl acetate. It would give us acetic acid and ethanol. And if you're looking at these reaction conditions, you might be thinking this looks a lot like a Fischer esterification, and that's because it is. And it's essentially a Fischer esterification in reverse. We're going to go over the mechanism right now, so when you see this on your exam, you can get it right. But just remember that this is happening in reverse, and this is why the acid catalyzed hydrolysis is not the best. Usually base is better because this is a reversible process. The first thing that's going to happen, we're going to protonate that carbonyl. Okay, we're going to get our oxygen with a positive charge, which it's not happy about. And the orbital geometry isn't right, but oh well. Now, this is primed for attack from water. Should have wrote water in there, I'm so sorry. We're going to nucleophilically attack this. And we're going to kick these electrons up here. Now, like I said, this is kind of just your Fischer esterification in reverse. We have H2O plus here. Now, there's a proton transfer step that happens here, just like in the Fischer esterification video. I'm not going to show it explicitly, but if your professor wants it, make sure you know what it is. And essentially, water coming in, grabbing this, then H3O plus protonating this. We have a proton transfer step where now our alcohol, or what was our alcohol, has a proton and is positively charged. And we have simply an OH here. And then what's going to happen, the electrons are going to come back down. We're going to kick off our alcohol. We're going to reform our carbonyl, albeit protonated again where it's not very happy. So we need to do something about that, and you simply have either you have water come and take this again. We're going to kick this down to our oxygen, recreating our carboxylic acid and then our alcohol as well.